Hello, and welcome to this section on time series decomposition. And in this section, we will discuss the components of a time series, why they are important, and how to isolate the different components. In this video, I will give you an intuition of what the components are, what they look like, and how to visually identify them. And in the next videos in this section, we'll discuss the different mathematical methods that we can use to capture each one of them, listing their advantages and their limitations, and how we can implement them in Python. So let's get started. So in this lecture, we'll be talking about how we can break a time series down into multiple components, and we'll explain why this is useful. Now let's talk about time series components. Time series can sometimes be broken down into individual components, typically a trend component, seasonal component, and a residual component. Let's look at a specific example. Here is a dataset of monthly sales from an online retailer. As we can see, there is an overall trend where the sales increases with time. There is also a seasonal component, as we can see that the sales spikes every December. And then there is a residual component. This is all the variation that we see in the data once we take into account the trend and seasonality. Let's discuss the trend. By trend, we mean a long-term increase or decrease in the baseline of the time series, and this is not necessarily linear. We represent the trend here by the orange line, and is something that we might draw by eye. Let's talk about the seasonal component. By seasonality, we mean a fixed periodic pattern that occurs in the time series, and this pattern typically relates to seasonal factors, such as the time of year or day of the week. Examples of this would include things like Black Friday and Christmas, where we might expect additional sales to occur, or during times like school holidays where there might be a lot of tourism. And so as you can see, there are many different factors that could drive periodic seasonal behavior. Let's return to our example time series now. Let's see if we can highlight aspects of this time series to highlight the seasonality. If we highlight some years, we can illustrate that there is yearly seasonality, that is, a repeating pattern that occurs every year. So if we highlight some of these years in red and plot them individually, we can spot that there is a pattern that occurs each year irrespective of the overall trend. We can see each year that we have a low point starting in January, and the dataset then levels off, followed by a spike in December. Despite the baseline of the time series changing, we'll see that it will be useful to extract this periodic pattern quantitatively for many purposes later on. Finally, let's discuss the residual component. The residual component is also known as the remainder component or irregular component, and it contains everything left over after subtracting or dividing out the trend and seasonal components. Here we show an example of the original time series and the extracted trend and seasonal components. Once subtracted from the original time series, we can see the residuals here. We shall show later that it can be useful to examine the residuals to determine how much structure of the underlying time series is captured in the trend and seasonality. If the residuals are large, it means that there is additional information that we have not managed to extract through the trend or seasonal component. Or it could mean that our methods for estimating the trend and seasonal component could be improved. Let's discuss what it means to break a time series down into components and how they can be brought back together to recover the original time series. Once we have extracted the individual components, for example the trend component, seasonal component, and residual component, we could either sum or multiply them together to try to recover the original time series. Whether or not you should choose a model which sums them or multiplies the components together, we will discuss in the next lecture. So why is time series decomposition useful? Well, the answer is that there are many applications. For example, in exploratory data analysis. Imagine you sold shorts and they sell more in the summer. You might want to answer the question, such as, what was the impact of an advertising campaign once we account for seasonality? It would be useful to extract the seasonality here so we can understand how much of the uplift in demand was due to the advertising campaign as opposed to the fact that it is just the summer period. We can also use time series decomposition methods to pre-process the data. For example, we can identify outliers and impute those outliers and missing data using time series decomposition techniques. There is also an application in feature engineering. We can derive features from the individual components that we extract and use them as inputs into machine learning models. And we can also use those components for forecasting. It's a typical application where the individual components, for example the trend, is forecasted out and the seasonal component simply repeated, and these are then aggregated to produce a final forecast. We note that it is not always possible to use time series decomposition methods, and this is because not all time series can easily be broken down into components. Here is an example of weekly online sales revenue. As we can see, there is no strong seasonal or trend component in the data, and therefore time series decomposition methods would not give us appropriate results. It is important to plot the data and check this beforehand before you use time series decomposition methods. Let's summarize what we've learnt in this lecture. Time series can be decomposed into components. Typically this would be a trend, seasonality, and residual component, and that this decomposition can be used in multiple ways, including exploratory data analysis, feature engineering, pre-processing, and forecasting. So it's certainly a topic worth learning about. See you in the next lecture.